Okay, we are going to get started here. So, first of all, are there any questions that you have that you want to ask about before we get into the other things? Anything from homework, quizzes, anything like that?
Hi, good afternoon.
Hi, how are you?
I'm good. I don't know if it may work for all, but I think it would be nice if we just look over the questions and maybe some personal questions uh after that.
Yeah, we can do that. Just want to make sure you speak up if you do have any questions, because I want to make sure that we get any of them answered that you guys have. So the test will be 16 questions long. You'll have 2 hours to take it. You can use a scientific calculator, so make sure you remember those things. If you haven't signed up, it looked like only half of the students, when I went in earlier today, have signed up for, registered for it. So please, please, please make sure you get that done. You can take it on Monday or Tuesday. Okay, so you just need to sign up for a time that works for you on Monday or Tuesday.
I do have a question.
Mm-hmm.
For the quiz, is it the third quiz that we have after this module? Do we have to do the written one? Because we didn't get anything for that in class.
Yeah, so you still need to do it. It's there on Canvas. I think I mentioned when I handed out the first one, sometimes we'll have time to work on them in class and sometimes we won't. But yeah, you still will be responsible to get those turned in. Thanks for asking. Yeah, and then you're just due by midnight on the 17th, so the last day that you can take the exam. You will have until then to get those uploaded. Okay.
I have another question. So the other day, I think before the last class, you gave us like a paper, like a homework. Like I think it's Module 2 quiz. And I did that homework, but I have problems submitting that in the real like Canvas assignment. So I was asking if I can send that paper, the picture, through your Canvas inbox.
No, you need to upload it to the assignment. So you need to make sure that you're changing your, when you take a picture of it, make sure you change it to a PDF, because that's the only type of file that it's going to be able to read. And so if you aren't quite sure how to do that, there was an assignment in the orientation module where you needed to do that, to change a picture to a PDF. So you can use something like Cam Scanner or Adobe Scan. There's a bunch of different apps you can get on your phone that will do that for you. So
yeah, but that was not the problem. The problem was that I submit the Module 1 quiz in the Module 2.
Oh.
So it got, and I was trying to resubmit it.
So did you?
And there was no the option.
Right, because I just have it just with one attempt on there. So you put the Module 1 quiz then on both Module 1 and Module 2?
Yes, that's what I did.
Okay, send me a message on Canvas and then I can, we can talk about how we can fix that. But I don't want you to send it through Canvas because it just, I just won't see it there and I won't be able to give you feedback on it that way. Okay?
Okay. Okay, well, thank you.
Send me a message and we'll get it figured out for you. Okay. Awesome. All right, so let's go ahead and just kind of look through some of the things that we're going to be doing on Exam 1. Remember that it's going to cover Modules 1 through 3, or that's also Chapters 2 through 4. And so make sure that you're studying all of that material for it. So in the first module, we talked a lot about graphing and being able to graph these things on a grid. So it's important to do this. So this was just, to give you some practice. I just want to make sure that you know how to graph certain lines on the grid. So remember we talked about how if I look at this first one, let's see, make that one green. We're going to start at that y-intercept, which is 4. So going up 4 places. I'm just going to use, there's these little lines there, but I'm going to say each of those lines are a half because it just gets really hard to see. 1, 2, 3, 4, right? So does everybody see what I mean? Like those little blue lines are what I'm going off of. Or can you guys not see the blue lines? Can you see them? Yeah? Okay. So,
Really small.
say that again.
I said they're really small.
They're really small, I know. Here, maybe I'll try and do this on it. Is that a little bit better? Okay, and then a slope on it is, and the number in front of our x, which is going to be 1 over 1. So we're going to go up 1 and to the right 1, or we could go down 1 and to the left 1. Right, and then our line would be something like that if you were doing that. Okay, or if we're doing this one, so I want somebody to tell me where would we start to graph this bottom line? A different color.
We would start at -1.
So put down 1 there, okay.
Go up 3 and 4 to the right.
Okay, yep, so up 3, so 1, 2, 3, and over 4, 1, 2, 3, 4. And so just, make sure that you kind of, it should just look something like that. All right, so just know how to graph some lines. Is all I'm trying to make sure that you remember how to do here. If it's in a form like 2x plus 3y equals -6, then you could get it into that slope-intercept form, right? Get y by itself so that you can graph it in that same way. Or you could just graph it using intercepts. So meaning if you let x, oops, I put that in the wrong place. If you let x equal 0, then you solve for y. If you let y equal 0 and solve for x, those will give you your, so this is your y-intercept, and this would be your x-intercept. So just review all of those different ways that you can, I'm not supposed to say y, solve these, or sorry, graph them, I should say. Okay, what about the domain? So we have a fraction here. How are we going to find, first of all, the excluded value? So what number can x not be? How do we find that?
-6 because you can't have the domain 0.
Okay. Yeah, so if we take this 6 minus x cannot equal 0, right? Then just like you said, we could just add the x over there if we wanted. Then x cannot be 6. So it can be any other number there, just not 6, right? So you see that in there? Because if I put 6 in place of x, that's going to give me 0. So it can't be 6, but it wants the domain, right, in interval notation. So remember, if I'm thinking about a number line here, we're saying it can't be 6, so it's like there's an open circle there, but it could be anything smaller than 6, anything bigger than 6. So how do I write that in interval notation? Any remember? Read your graph from left to right. So how far to the left is this going to go?
Is it -1? I mean -infinity,
Yeah.
comma.
So put parenthesis, -infinity, comma.
The comma 6.
Uh-huh.
Then close parenthesis. I don't know if it will be a union.
Yeah, there's going to be a union. Yep, because this is saying it doesn't include 6, right? So we're trying to write this same thing out, but just in interval notation. So -infinity to 6, and then 6 to infinity. All right? Because that's, like when you're looking at the graph here, right, it just can't be.
It can't be 6.
Yeah. And why can't it be 6?
Is it because it makes it 0?
Yeah, it makes the denominator 0. We can't divide by 0, right? So we gotta be careful with that. Okay, so let's look at this next one. This is another graphing one, and this time it was those intercepts like I was talking about before that we could use. So when it's asking you to graph finding the intercepts, like I said, you could make kind of a little table of values saying, all right, I want to figure out when x is 0, what is y? When y is 0, what is x? And then I can find out where those are crossing the x-axis and be able to graph it that way. Okay, so if we look at this one first, right, I'm putting 0 in place of x. So I've got 3 times 0 plus 2y equals negative 18. And so that's just gone. And I just have 2 to divide by. I don't know why that ended up so far over there. Sorry about that. But y equals negative 9. Okay, so this is the y-intercept, but we want to write it as an ordered pair. Right? Do you see that this is the ordered pair, 0, comma, negative 9. When x is 0, y is negative 9. And now we're just going to do this, but now put y, right? Replace that y with a 0. So 3x plus 2 times 0 equals negative 18. Well, our 0, that part's gone. 0 times anything is 0. And let's divide by 3. So x equals
6.
negative 6. You guys got it? And so, again, on the test, it will probably ask you to write these x-intercepts as ordered pairs. So make sure that you know how to do that. And then we're just graphing those two. So over 0, down 9. Let's see. Oh, gosh, those are so small. Oops, but now all right, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so barely fit there. And then, so that's my y-intercept, my x-intercept. All right, it's going to be on the x-axis, and that's at negative 6. 1, 2, 3, 4, 5, 6 right there. And then we just need to connect those together, and that would be the graph of the line. Okay? All right. Okay, any questions there? Okay, let's look at the next one. All right, so first of all, I want to make sure that you have these memorized. So right now on your paper, I want you to try and write down these formulas. So slope-intercept form, the slope of the line, and point-slope form. Okay, because those are 3 formulas you need to have memorized for the test. Try and do it without looking at your notes and see what you can do. There, I just muted it. What are you doing? Did you have some questions? Just gonna hang out until 5? This is done? Okay. Yeah? Of course I am. Mm-hmm. No, my face isn't looking like they are. Just nice to see you. Yeah. I am. I muted it. see what you're going to do. All right, so somebody share with me what you got there. What is slope-intercept form?
Is that one the slope equals to y2 minus y1? And
So that's the slope of the line. Yep, so slope of the line. So m, oops, why did it do that? Hold on a second. Maybe I'll put that over here. It's kind of hard to write in that place. So slope is, okay, I don't know what's happening here. My computer is wigging out. All right, but that's the y2 minus y1 over x2 minus x1. And that's what you were saying, right? Huh. I really don't know what's going on now. Sometimes it just has a mind of its own. Try putting it over here. Oh my gosh. This has never happened to me. What in the hell? Okay. Okay, so y2 minus y1 equals x2, or over x2 minus x1. So the thing that's important on that, make sure that you have the y's on the top and the x's on the bottom, because the most common mistake on the test is to flip-flop that and have the x's on the top and the y's on the bottom. Okay, so what about slope-intercept form? What is that? Come on. Somebody else can. Brian, do you remember what that one is?
Hey,
Say that
I'm
again?
pretty sure that I already share the formula in the comments.
Oh, okay.
Maybe.
All right, let's see what you put there, Brian. I didn't see it. Okay, yeah. So y equals mx plus b is correct. I might have to go out of this and come back in. Just 1 second. Let me see if that's going to work. Okay. Notes. Okay, yeah. It was just doing something weird, so I had to get out and back in to make it work. So, all right. And then what about the point slope form of a line? Remember what that one is?
Is the formula where is y less y1 equal to m parenthesis x negative x1, right?
Yes, that is correct. Right. So y minus y1 equals m times x minus x1. And so you'll always use, you can use this formula when you're trying to find an equation of a line. Right. That's when we want to use that one. Okay, so speaking of which, find an equation in slope-intercept form of the line containing those 2 points. So if we're trying to use this point-slope formula, we need to know the slope, and we need to know a point. Well, we've got a point, but we don't have the slope. Could we find the slope?
we can't see the whiteboard that you just had up.
Thank you. That would be good to know. I'm just writing it here, thinking that you guys could see it. Thank you for letting me know. Is that better? Can you see it now? Okay. All right. Okay, so we've got our y1 or x1, y1 or x2, y2. So what can we do with those?
Put them in the slope of the line formula.
Yeah, so let's use that slope formula. So we'll do the y2 minus y1, so 4 minus 8. And then what's going to be on the bottom?
The 1 minus 3?
Yeah, 1 minus 3. Okay, so on top we get negative 4, on the bottom we get negative 2. When we divide those, what do we end up with? 2. Okay, so now we know the slope, and now we have a point here. So now we can use both of those in that point slope form. So now I'll do y minus y1, which I'm calling 8 here. You could use either point, remember. I'm just choosing to use this one because I already labeled it as x1, y1. Okay, so y minus 8 equals, my m is 2, and then x minus 3. Distribute that through, because now we need to get it into point or the slope-intercept form. And so that means we need to get y by itself. All right, so we end up with y equals 2x plus 2. Everybody see how got that, or questions? So we had to find the slope first, then we can use one of the points to put the information into this formula. Doing good? Okay. All right. Let's change this next one though. Instead of parallel, let's do perpendicular. So remember, parallel lines have the same slope, but perpendicular lines have what kind of slope?
Isn't it negative? And doesn't it also flip?
Yeah.
Isn't it?
Yeah, so if it was 2/3, then the perpendicular slope would be negative 3/2, right? Change the sign and flip it. Okay, so how are we going to figure out what the slope is here? Can we tell what the slope is right away looking at this equation?
1/2.
Yeah, so we have to do some work to figure it out, right? So we need to get that y by itself, so let's do that. Can't just see it right there. So we can subtract the x over, and then we'll divide by negative 2. Okay, so we got y equals 1/2 x plus 3/2. So 1/2 is our slope for this.
It should be negative 3/2 because you're dividing by
Oh,
negative.
thank you. I'll put that negative right there. Yes. Although on this one, all we need is that slope, right? So yeah, but be careful with your signs. It's so easy to make mistakes with signs. I do it too. So, all right. So, is that the slope that we want to use in the point slope formula?
Yes, because that's our slope.
Is
Yeah.
it?
Or, I'm not sure. Oh, perpendicular. No, we have to flip it and it would be negative 2.
Okay, yep. So flip it and change the sign. So our perpendicular slope is going to be negative 2. Good job. Okay, so then help me fill out the formula. So y minus what?
5.
Mm-hmm. Right. Equals
The negative 2.
negative 2, parenthesis, x.
X.
Go ahead.
Oh, okay. X minus 5.
Look at it again.
Oh, sorry. 2.
Yep, x minus 2. Good job. Okay, then let's distribute that through. So y minus 5 equals negative 2x plus 4, and then add the 5 over. So y equals negative 2x plus 9. Okay. You getting it? You going to be able to do one of those on the test? Yeah? Okay. So I'm going to skip over this one with the perpendicular one. If you want to write that down, and you could go through it yourself just to see if you can figure that out. That would be a really good thing to do. But I'm going to skip it since we just did one of those, the perpendicular. Get that. Okay, so let's talk about solving systems of equations. So with the substitution method is what it's asking us to do on this first one. What do we need to do? How do we do the substitution method?
We plug in that x equals to 2y minus 1 in the 3 plus where it says x.
Yeah. All right, so we have x by itself already in that bottom equation. If we didn't, we need to get one of the variables by itself. But we do have it, so we're going to take that and then just plug it into the x there. All right? So I'll have 3y plus, and then instead of x, I'm going to put 2y minus 1 equals 4. And then I just need to solve for y. So 5y minus 1 equals 4. Let's add the 1 over. 5y equals 5, so y equals 1. Am I done?
No, we still need the x.
Yeah, we gotta have the x too. So remember to write your answer as an ordered pair, right? So that's our y is 1, so we'll put it there. Okay, so what am I going to do with this y equals 1 now that I found it?
We could plug it into the x that it's by itself, x equals to 2y, because it's easier to find.
Yeah, so I would put it right here. X is already by itself in that second equation, so let's just put it in there. So x equals 2 times 1 minus 1. So x equals 2 minus 1, which is 1. Right. So my ordered pair, the point in which those two lines would cross each other would be at the point 1, comma 1. All right, so that's the substitution method. Right? Get one of those variables by itself to solve it that way. What about the elimination method? So I'm trying to eliminate one of the variables. So if we add them together like they are right now, will either of the variables eliminate?
No.
No. So how can we make it do that? We've got to make one of the variables eliminate. So let's say we're trying to eliminate the s's. Okay. What would I need to multiply this top equation by?
6.
Okay, 6. If we did that top one by 6, what would we do the bottom one by?
Negative 8.
Yeah. Why did you say negative 8, not just positive 8?
Because positive and negative cancel each other out.
Yeah, we need to have one of them be a positive number, one needs to be a negative, so they zero out. Okay, so let's see. Let's go ahead and rewrite these again. So we'd have 48s plus 12t equals 16. And then negative 48s minus 72t equals negative 96.
Oh wait, you didn't multiply the top one by 6. The 12.
Oh, yeah, I didn't do the 16 by 6. What is 6 times 16? Thank you. All right, I'm going to have a little cough attack.
The 16 times 6 is 96.
Okay.
And the 12 times 6 is 72 also.
Thank you. Okay, so what happens on this one then? So when I'm adding these together, I was trying to get rid of those S's, right, which I did, but in the process of that, what else happened?
I'm going to cancel out everything.
Yeah, the T's are gone, so I'm left with 0 on the left side, and then 96 minus 96 is also 0. Okay, so what do we do when we come up with an answer like that? Is the answer 0?
State infinite. No, state infinite answers.
Yeah, infinite solutions, exactly. What if it said 0 equals -3?
That's no solution.
NA.
Yep, then DNE, no solution, something like that. Okay, good job. So make sure you can tell when something is an infinite solution compared to a no solution. So hint, 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 there might be one of those on the exam. All right, just want to make sure you know those in between those two. Okay, guys' favorite kind of problems, right? The percent mixture problems. Everybody loves it. Yeah, I know. See the look on your faces. You're like, no way. Okay, so Deep Thought granola is 25% nuts and dried fruit. So that's together. It's just kind of weird that they say it that way. Right? And then the Oat Dream granola is 10% nuts and dried fruit. How much Deep Thought and how much Oat Dream should be mixed to form a 20-pound batch that is a 19% mixture of nuts and dried fruit? All right. So I like to put it in a table. But remember, if you don't need to do that, if you don't like to do that, you don't have to. Just use whatever works best for your brain. Okay, but I like to put what we're mixing together along the top. So we know that we're taking a 25% mixture and we're mixing it with a 10%, and we want to end up with 19%. All right? So that 19% is our total. Okay, now down the other side here, I want you to think about what units or labels we have in the question. So I can see that we're talking about pounds, so that needs to be part of it. And then the other part is percent signs. You can see those. So in this row, remember, we're just changing that percent to a decimal. And then this last row is going to be the total. Okay. So now what? So now that we got that all labeled, all right, let's look at the pounds. What do we know about the pounds?
We know that we only, at the end, we'll need 20 pounds.
Yeah, so we know the total has to be 20. All right, do we know how many pounds of the 25%? Nope, so I'm going to call that X. That's one of the things I'm trying to find. And I'll call the 10%. Many pounds of the 10% I'll call Y. Okay, and that makes my first equation. That is the X plus Y equals 20. Okay, then on this next row, go ahead and just change your percent to a decimal. So what is 25% as a decimal?
0.25.
Mm-hmm. And then 0.1, and then 0.19. Okay, now how do I get the stuff in that third row?
25x.
Yeah, so we're going to multiply these two together, right? So 0.25x, 0.1y, and then how do we get this one?
Multiply.
Okay, well, so it's 20 times 0.19.
Should be 3.8.
Okay. All right, and that's my second one. All right, so 0.25x plus 0.1y equals 3.8. And then from here, you can choose to solve it by substitution or elimination. It's pretty easy to get like the x or the y by itself, right? I could get the x by itself by subtracting the y over. So that would give me x equals 20 minus y. So it's pretty easy to do that. So a lot of people, I think, might think to do substitution. So then we'll take that 20 minus x, or sorry, 20 minus y, and put it in place of x here. Right. Okay, so let's do that. So 0.25 parenthesis 20 minus y plus 0.1y equals 3.8. Okay, now let's distribute this through. So what's 0.25 times 20?
Should be 5.
5. And then so minus 0.25y plus 0.1y equals 3.8. What should we do now?
We could add the 0.1 to the negative 0.25.
Yeah, let's combine those together. So what's negative 0.25 plus 0.1?
Should be 0.35.
Look at it again. So this was a subtract.
Oh wait, it is a
This was
subtract.
that.
Sorry.
You're okay. It's an easy mistake to make.
Should be negative 0.15.
Yes. All right, now what?
Can move over the 5, subtract it over.
Okay. So that is 3.8 minus 5.
Should be negative 1.2.
Okay, so we have negative 1.5y equals negative 1.2. Divide by negative 0.15. What do we come up with?
8.
What'd you say?
8.
8. Okay, so 8 what? Remember, if we have a word question, we need a word answer.
Should be 8 pounds.
8 pounds of
Dried fruits and
but which percentage?
for the 10%.
Yeah, right? Because over here, that's what we labeled it as. That 10% was our y. Right? So that's what we want. So 8 pounds of the 10% mixture. Okay, then how would we find the other part? No, the pounds of the other one.
You could plug it into the first equation because it's easy, simple, just for the y.
Yeah, we can plug it in right here, right? So put y, or 8 in place of the y. So x equals 20 minus 8. And what is 20 minus 8?
Should be 16. Oh wait, sorry. Geez, 12.
12, that's okay. So 12 pounds of what?
The 25%.
Okay, and then that is done. Okay, so were the questions back here on the setting it up? Because I think the solving of it usually goes pretty smoothly, but the setting it up usually is the tricky part on this one. That makes sense, or do you have questions?
It makes sense. I feel like the tables really do help.
I think it does. It helps me organize the information. That's why I like it, but you know, some people don't, so that's just fine. Okay, let's do a little problem like this. Right, another story problem. Cody's motorboat took 3 hours to make a trip downstream with a 6 mile per hour current. The return trip against the same current took 5 hours. Find the speed of the boat in still water. So remember in class when I was talking about how rate is made up of 2 different things, right? So it's the speed of the boat plus or minus the speed of the current. Alright. This, make sure you remember this for the test. Usually if people miss this problem, it's because they've forgotten this. All right, so that's going to be helpful when we set this up. So I'm going to make another table. I like tables to keep organized. All right, so here we've got the distance, rate, and the time is what they're giving us information about. We know about downstream and upstream. Okay, so let's fill in what we know. So where's that 3 going to go?
Downstream?
Okay, yeah, so 3 hours downstream. So where is it going to go in the downstream?
And the T for time.
Yeah, under T for time. So 3 goes there. And then how many hours does it take upstream? 5. Okay, now, so this is the part with the rate here, right? We are given the speed of the current, but we don't know the speed of the boat. So I'm going to call the speed of the boat, I'm going to call it B. Okay, that's what we're trying to solve for. And we also don't know anything about the distance, just that it's the same because you went downstream and then you went up the same, way, but just went upstream. So we know those distances are the same. So I'm going to just put those both as D. And so how would I write this? So downstream, right, is that going to be, how are we going to write that?
Wouldn't that be, I don't know, D plus X, because isn't it?
So
sorry.
Yeah, so what is the speed of the current? You see it there? 6 miles per hour. So we'll have B plus 6, right? And why the plus sign? Why not the minus? Why is it plus?
Isn't it because you're not like going against it and you're going like down?
Right? That current is pushing you 6 miles an hour faster. Right? Where the other one, where you're going upstream you're going against the current. So it's slowing you down. So that's why that one's B minus 6. Okay, so then we have D equals 3 times B plus 6. And D equals 5 times B minus 6. Okay, what can we do from here?
I like to divide like the 3 like on that side so it could cancel out, then multiply it on the other side.
Yeah, so with this one, if this was a number here, right? I like to do it that way too. If we divide by a 3 here, that's just going to give us kind of a weird fraction, D over 3. Do you see that? So I like that idea if we knew the distance. That would be really good. But on this one, since we don't know the distance, how about we just distribute it through this time? Is that good? Okay, so let's see what we get there. I'm going to put them down here. So 3B plus 18 equals 5B minus 30. Okay, and then we just need to solve it. Let's subtract the 3B over. We get 2B, add the 30 over. So 18 plus 30 is 48. And then divide by 2. So what's 48 divided by 2?
Should be 24.
24, and so 24 what? We need a word answer. 24 is the speed of the boat, right? So what would our label on that be?
Just the speed of the boat? I'm not sure.
So like, yeah, so it needs to be like 24 miles per hour. Yeah. So we need to put that label on there, the units, right, what we're dealing with there. And then that's done. That's all it's asking us to do is just find the speed of the boat with that. Okay, so if they give you the current like this, then make sure you remember to put that in as part of the rate. Okay, I think I'm going to skip this one too. If you want to write that one down, you can, but it just gives you a little bit of, more help. And on this one, you could solve it using either method. It doesn't say, where on the other ones it kind of asked you to do that, using the substitution or elimination. Because I definitely want to get through a 3x3 equation, so we can do that. Okay, so let's try this one. Okay, so first thing you want to do is decide which variable you want to eliminate. So which one looks the easiest to eliminate? The x, y, or the z? What are you thinking? I'd say the y's, and this is y. All right, so here I have a positive y, and there I have a negative y. So already those are going to zero out. Right? And then it would be pretty easy to eliminate this one if I multiply that bottom equation by 3. So the y's to me look the easiest to eliminate. So let's try that. Let's do equation 1 and equation 3, put those together. Okay, so the y's are gone. Right, we were trying to eliminate them, we did. And then we just need to add the rest together. So x plus 2x is 3x. Negative 3z plus z is negative 2z. And then 4 minus 14 is negative 10. Okay, and then I'm going to call this equation 4. And I'll come back to it in a minute, right? Because now I have to go back to the original 3 and pick 2 others. So I'm going to pick 2 and 3, and that's just because this one already has the negative in it. Then I don't have to multiply a negative through, because, I mean, it's just easy to make mistakes with negatives. So if I don't have to multiply by a negative, I'd rather not. So I'll have equation 2 and equation 3. So equation 2 and then equation 3 right here, and then I'm going to show that I need to multiply it by what?
3.
By 3. So we can make those eliminate out. All right, so when I multiply that through, I get 6x minus 3y plus 3z equals, what's 14 times 3?
42.
Oh, sorry, negative 42.
Yep, negative 42, good. Okay, and now I can see, I'm just going to put a line through that so I don't get mixed up here. All right, but I can see now that my y's are eliminated, so that's good. And then what am I left with when I add the rest of it together?
8x plus 4z.
Oops, I said 4 and I wrote 3. 4z, okay.
It should be equals to negative 36.
Yes. Okay, so now I'll call this equation 5. Now what should we do?
Now we put equation 4 and 5 together to either cancel out x or z.
Okay, so let me put it underneath here, and then you decide which variable looks easier to eliminate, the x's or the z's?
I say the z's.
Do you agree, Brian? Yeah, thumbs up. Okay, so I agree with you too, because if we multiply this by what?
Like, if we multiply either the top or the bottom by -8 or like 3, it would just be
Oh, wait a
big
minute.
numbers.
I thought you said z's were the easiest to eliminate.
Yes, that's what. Oh, sorry, I thought you were talking about why we shouldn't. do that.
Oh, I see what you mean. Yeah, okay, no. So yeah, so we multiply the top equation by 2, right, is what you were thinking. Okay, yeah. So let's distribute that through. That'll give me 6x minus 4z equals -20. So the z's are gone. I did that on purpose. Now what am I left with?
14x equals to negative, yes, 56.
56, okay, and then we divide by 14.
-4.
-4. And are we done? If only, right? Okay, so we got that there. We still need to find the y and z. But remember that first one is always the longest to get. Okay, so how can we use this x equals -4 to find another one?
We could plug it into one of the 4 or 5 equations that we made.
Yeah, and I'm going to put it right there. Right, looks like it'll be easiest to do that. So I've got 8 times -4 plus 4z equals -36. I've got -32 plus 4z equals -36. Let's add the 32 over. So I get 4z equals, oops, that doesn't look like a 32, equals 4, right? -4. Sorry, I'm having a hard time reading my own handwriting here. Divide by 4, so z equals what?
-1.
-1, so I'll put that up here, and then how can I use this one? So I know what x is, I know what z is. How do I find y?
Can plug it into the very first one.
Yeah, that one looks the easiest, I think. Let's plug it into equation 1. So x is -4, y is what I don't know. Then -3 times z, I found z to be -1, so let's put that in there, and equals 4. All right, let's simplify this. Oops. Plus 3 equals 4. So I've got -1 plus y equals 4. And I just need to add the 1 over. So y equals 5. Is that what you guys came up with?
Yes.
And so that would be our answer, that ordered triple right there. -4, 5, -1. And remember, if you, I told you on in class that these will not come out to be fractional answers, right? So if you come up with a fraction, then you probably made a mistake with a negative somewhere. So go back and see if you can try and find your mistake. Sometimes you just might have to rework the problem out. Now, on the exam, when you're taking it at the testing center, they'll give you scratch paper. However, they're going to shred it after, so you need to make sure that on the test is all of the stuff that you want me to grade, because I will not see that paper. Okay, so make sure that you get that written on there, just that part that you want. Okay, just a couple more questions here. All right, just a few more here. So graph and write the interval notation for this compound inequality. Remember, when I read this, I can read this as x is between -8 and -2, including -2. Like x is actually like between. I mean, look at it. It's like stuck in between it. So when I'm trying to graph that, oops, I'm going to use for the number line. So when I'm trying to graph this, I've got -8 somewhere here, -2 here. Now next to the 8, I have an open circle, and next to the -2, I have the equal to part, so that's a closed circle. And then I want all this stuff, x is all the stuff between those two numbers, so that would be my graph. Right. Then how do I write that in interval notation?
Is it parenthesis -8 common, -2, then that one is the bracket, not the parenthesis.
Exactly, right? Since it's a closed circle, had that equal to part, has to be that closed bracket. Okay, and that would be your answer. So it wasn't too painful, huh? Okay, what about absolute value equations, right? Like we talked about last time. So what do we need to do first? We're going to end up writing two different equations, but before we can write those two equations, what do we need to do?
First, subtract 3 over.
Yeah, we got to get that absolute value part by itself. So you're right. Let's start by subtracting the 3 over. So that will give me 2 times the absolute value of 2x minus 3 is equal to 4. And now what?
Then do we divide by 2?
Divide by 2, right? Because we need to get that absolute value part by itself. So then I end up with, I'm going to write it up here, absolute value of 2x minus 3 equals 2. And now I need to write my two equations. My first one is going to be just like this is without the absolute value bars. So 2x minus 3 equals 2. What changes on that second equation? We'll keep this as 2x minus 3. That's going to equal, we got to change that to the opposite, so it's going to equal -2. And then we'll just solve these down just like we normally would, right? So let's add the 3 over, 2x equals 5, we divide by 2, x equals 5/2 or 2.5, however you want to write that. And then here, again, we'll add the 3 over, so 2x equals 1, and then let's divide by 2, so x equals 1/2. And remember, we're going to end up with two different answers because we have to look at both cases, right? We don't know, like, if we're, like the absolute value of -3 is 3, the absolute value of +3 is 3. So there's two ways to get to the same answer. So that's why we need to have these two different equations that we write. Okay, and then this one's kind of similar to it, right? But now we have an inequality in there instead. So again, we still need to get that absolute value part by itself. So let's start by subtracting the 5. And so that'll give me absolute value of x minus 4 is greater than 5. And then I can write my two different statements from there. Okay, but remember those little things the little hints I gave you, the greater and less than. All right, so since this is a greater than sign, then I'm thinking greater, right? So it's an or statement, which means we're looking for the union of it. Right? So let's just write those two out here. Let's see. Choose that color instead. So we'll have x minus 4 is greater than 5, or what's my other one going to say?
X minus 4 is less than -5?
Yeah, you got it. All right, so flip the inequality and change the sign of it. And then we'll solve these out the rest of the way. So this one we get x is greater than 9, or let's add the 4 over there, x is less than negative 1. Okay. All right, and then we just need to put it on a number line so we can figure out how we're going to write it in interval notation. So I've got negative 1 here, positive 9 over here. So x is greater than 9. Open circle there, and everything greater than it is to the right. And the other one, x is less than negative 1. So again, an open circle here. And the stuff less than negative 1 is the stuff to the left. Okay, so how do I write that in interval notation now?
It would be negative infinity, comma, negative 1. And our u for the union. Then it should be 9, comma, infinity.
Okay, perfect. All right, so make sure you remember that greater or less than, right? Because it's not always, like if this was a less than symbol in between here instead of a greater than symbol, right, then we would be looking for the overlap, and there is no overlap, so it would be a no solution. So those signs are really important, those little and or ors, right, to give a different meaning. Okay, so let's start by getting these into slope-intercept form. I just need to subtract the x over. So that means I'm going to have y is less than or equal to negative x plus 6. And on this other one, let's subtract the x over. And that's going to give me negative y is less than or equal to 4. But then I have to divide by a negative 1, which is going to make what happen?
It's going to make it negative.
We're going to get a negative 4 over there. What's going to happen to our inequality symbol? Flip. It's got to flip. All right, got to flip it around like that. So be careful there. Whoops, what happened to my x? I just decided to get rid of it. Okay. Jokes. Let's try this again. That should be negative x plus 4. And divide both of those by negative 1. Alright, so we get, this is going to be positive x, and then minus 4. Okay, so then I'm going to have two different lines on here, and I've got to do some shading. Right? Let's say that this one just said less than, because I want to make sure that you understand, like, that you remember that when it's the equal to part, it's a solid line. When it doesn't have the equal to part, it's going to be a dotted line. Okay, so on this one, we started out just kind of like we did on that first problem that we did. So we're going to go down 4. And then where from there?
You go up 1, right 1.
Yep. 1, right 1, up 1, right 1, up 1, right 1. All right. Okay. So we'll just kind of try and draw that out. That's not a very straight line, but use your imagination. Okay, and then which side of that should be shaded?
So
X, or y is greater than this line. Where's the stuff that's greater than the line?
is it above?
Yeah, it's above. All the stuff up here. Okay, now let's graph the other one. I'm going to graph that one in purple. So we'll start at positive 6 up here. See if I can zoom it in a little bit more. Okay, so 1, 2, 3, 4, 5, 6 is there. And then where from there? Down 1 and right 1, because it's that negative 1 over 1. So down 1, right 1, down 1, right 1, and so on. All right, like that. Okay, and then this should be a dotted line because I changed it there, right? So it's just a less than. So let's just put it as a dotted line there. And then which side of that should be shaded?
Below?
Below, because it's less than, right? So when it has a less than, it's below, and it's greater than, it's above. Okay, but remember that this part in here where I have them crossing, right, this is my solution. So make sure on the test you shade this part in darker or something, make sure that it's really clear. You can even write me a like a note and say solution, right, is this part, is the part I mean. Okay, so make sure it's really clear where that overlap is. Okay. All right, well, those are all the questions that I have to go through with you guys. Did you think of any others that you might have? And if you don't, you can reach out to Ilma or me, right? She's on here. Is there anything that you want to say to him at all, Ilma?
Yes, I'm actually working on a message on Canvas to send out to you guys, and it's just about that GroupMe link. So once it's sent out, just make sure you go ahead and read it. It's going to be a super helpful tool, especially now since your exam's on Monday and Tuesday next week. And I'm basically talking about how I'm going to be available all throughout the weekend for you to either message me individually or send out a message in the group chat for me to answer any last minute questions.
Awesome. Thanks, Ilma. You guys are lucky. You got a learning assistant. So, utilize her. It's great. Okay? Sign up for that GroupMe. It will really be helpful for you guys to just be able to talk through ideas if you have a question on something or whatever. Okay? All right.
So are these exercises the most similar to the exam, right? Because it's the review?
Yeah, I mean, there definitely could be, more. So there is a review that you're going to do, wait a minute. Sorry, I keep getting confused between my two 1010 classes because you guys are using the old book and the other one's using the new book, and it makes my brain swirl. There's probably not. No, there should be. Is there a Module 1 review? There should be.
I saw one, if I'm not wrong.
Yeah, I think there is one there. And so I would say between this and that Module 1 review, I think it's under the the Exam 1 module, right? That between those two things, you should have a pretty good idea of what to expect to be on the exam. Okay?
Okay. Makes sense. Thank you.
Okay, you're welcome. You guys have a great night, and thank you guys for coming. And I'll get this posted in case there's things that you need to go back and look at, okay?
Okay. Thank you.
Okay, you're welcome.
Good luck on the exam.
Yes, definitely.